Wow, thanks. Can you hear me better now? About the same? Okay. So, it was a volunteer cause to, program a site to help get IT students, tech students in the public schools, internships. And so Jonas Stosky, does anyone know Jonas? Microsoft MVP, great guy. So, he's been on the advisory board as well. And we built this, and we started building this a few years ago. And it's been really good. This summer we're expecting about 800 to 900 companies to bring on about 4,000 interns. So Miami-Dade County yeah, how about that? 4,000 high school internships. So, it was a volunteer effort at the beginning, and they said, wow, this is great. We want more functionality. We want more functionality. And what's the story? Sure. Well, we can't keep doing this for free. So they've actually provided some funding this year. New functionality that we want to get developed and coded before the summer starts. So that's not much time. So if anyone might be interested in side projects, ideally someone who's got some full-time availability during the day and the evening to crank out these enhancements. But even if someone had 15, 20 hours a week, 10 to 15 hours a week, something like that. It's not volunteer work. You will be paid. It's not, grand, huge rates. It's not in the triple digits. I'll tell you that for sure. But it's also for a good cause. So that completes my recruitment effort. Thank you, Dave.
Thanks for sponsoring our meeting today. We have both soda, drinks. If anybody doesn't have a drink ticket, let me know, and some pizza. And I'm Dave Noderer. I run Florida.net and the Coders Cafe. And this is Damian Montero, another co-organizer of the event. And I like to just have everybody go around and introduce themselves. I'm a software developer. I've had my own business for 24 years, mostly .net and data.
My name is David Becker, freelance web developer.
Hey, I'm Rick Eckley. Hi, I'm Rick Eckley. I work for Citrix for about the last 6 years, and I do iOS development on the side. So if you need any work, let me know.
Name's David. I'm kind of hanging out. I'll be taking some pictures tonight, so wipe your tech face off when I come by, because you probably won't like what your tech face looks like.
Hello, I'm Scott Ketterincik. I'm a software developer. I do mostly C# and SQL Server.
Hi, good night. My name is Raul de Jesus. I own a software development shop here in Boca, and I'm available if you guys need help. We do Microsoft and also open source. We do Azure and AWS. We do mobile and web, full stack.
My name is Ken Wenyan. I've been writing software for 25 years. For the last 5 years, I've been doing Xamarin development work. I've done apps for Bloomin' Brands, which is the Outback Carrabba's Bonefish Grill mobile apps. And currently I work at Citigroup working on a new city news app.
Eric will get to introduce himself in a minute.
Hi, I'm Frank Roberge, senior software engineer. I've been doing this for a long time, and I've learned a lot. I'm going to learn more.
And if anybody's looking for developers or needs a job, definitely speak up.
My name is Freddie. My name is Freddie. I work for Apple as a tech support student, trying to get into development, trying to soak it up, all up, anything. Yeah.
Where are you going to school?
My name is Robert Brooks. I do tech consulting, mostly in the blockchain arena right now.
Are you finding business doing it?
Mira Rathod, and I'm a software developer.
My name is Sergio. I have a full-time position in a law office industry in Boca Raton.
David Cobb, interested in Azure, PowerShell, SQL.
And by the way, for the intern site, it's all in ASP.NET, MVC, and JavaScript. So, it's straightforward.
William Alvarez, software engineer.
I'm Brett Wright. I'm also a software developer, primarily with .NET and iOS.
Tim Clem, software engineer, just broadening my horizons.
All right, thanks. All right, our speakers tonight are Jason and Eric, and I'll let them introduce themselves in more detail.
Before we start, guys, this place is provided by Sendine Spaces. Those are the people over there. I always tell you guys, if you need a co-working space, look somewhere else. She fills the places like you wouldn't believe as fast. I work there only because I help run these groups and all that. Otherwise, I wouldn't be able to get in. So normally I would tell you, if you need a co-working space, go ask her. If you need a working space, go ask her quickly. She might have one available for you. Oh no, it's amazing. And all of Boca is here.
All right. Battery didn't. Nope, battery's on. All right, so my name is Jason Milgram, and everyone was introducing themselves. I will say that I used to be a software developer. Now I'm management, so boo. But to make up for the fact that we also have Eric here with me. So Eric, you want to introduce yourself with the disappearing mic?
Hi, I'm Erick Bacallao. I'm a software developer. We work a lot on Azure and .NET. Yeah, you know me.
Okay. So a little more background. We both work for Champion Solutions Group, which is headquartered in Boca Raton. It's been around since 1979. Eric and I had the great opportunity to be acquired. Our company was acquired by their company, coming up on 3 years. So for those of you who I know from past events, if you haven't seen me in 3 years, it's because they've been working me very, very hard. But welcome to Azure Service Fabric. So quick question, who here is using Azure Service Fabric right now? Anyone playing with it? And is my audio okay? Okay, great. All right, now it's official, Azure Service Fabric. All right, so we had a lot of developers in here. Everyone's familiar, I think, with the term infrastructure as a service, doing software development on virtual machines. Then we have platform as a service. So in Azure, you have app services. Anyone done any Azure app service development? Okay, so as a paradigm shift, virtual machines, you own the virtual machine, do whatever you want with it. If you want to scale it, you can have multiple instances, or you can do replicas with replication. You can put a load balancer in front of it. That's infrastructure as a service. Platform as a service, it took care of load balancing and scaling for you. You could put some easy configuration rules in there and have an instance scale up or scale down based on a variety of criteria. It did all the load balancing for you, the clustering. You didn't have to worry about any of that. You were just concerned about the data and the application itself. Then came Service Fabric. And I'll back up because Service Fabric has actually been around for quite some time. Azure itself uses Service Fabric. It has for years and years and years. What is new is they released the SDK, the Software Development Kit, so that we could start utilizing Service Fabric features. So it is actually a very mature offering. What is new and became more mature quickly were the developer tools available to us in order to utilize Service Fabric. Who here does works with containers? Kubernetes. Okay. So Azure Service Fabric is a microservices platform, very similar to a Kubernetes container. One is not better than the other. They're just different services. So the advantages of a Service Fabric solution. I'm not really going to, well, I'll kind of read the slides to you. One of the interesting things is when you build on Service Fabric, you can run it locally on your PC, your laptop. You can run it in Amazon. You can run it in any public cloud. And that's because the kit that you download, it's the same bytes that you run locally that are run in Azure, which is another good thing. So anyone who's worked with app services, you know, you sometimes built an app service and it works on your local machine, and then when you deploy to Azure, something's not working the same, and you're not quite sure why sometimes. With Service Fabric, it's different. It is the exact same bits. It solves a number of interesting problems and adds some competitive edge to Microsoft because you can build a Service Fabric cluster, run it on-prem, run Azure, run Amazon, doesn't matter. So that's one unique feature. The other, you know, just dealing with kind of the microservices platform, the containerization effort, everything becomes very finely layered. And what that allows you to do is what they call rolling upgrades. You can upgrade the solution without bringing it down, because instead of upgrading the whole, you know, app, you just upgrade a little piece of it without bringing the other parts down. We have some visualizations. What we're going to do is kind of give you a quick high-level overview. Then we're going to show you a Azure Service Fabric solution that we have running in production. Then we're going to go through some more PowerPoints on concepts, and then we'll actually show you Azure Service Fabric for real with some code examples. Any questions so far? Yes. Ooh, okay, so in Azure you have Azure App Services, which I'm going to say might be the same as a cloud service. It's just not on this machine. I have another slide that goes, I think, does a really good job showing the differences between infrastructure as a service and platform as a service. One primary thing is with infrastructure as a service, the hardware is abstracted from you. You're using a virtual machine, wherever it's running. With platform as a service, even more is abstracted from you, and you're just concerned about the code and the data. You deploy it, and you can create rules to scale up and scale down. It will take care of clustering for you. With Service Fabric, it's that next paradigm shift in software development. And important point, and we'll talk about it a little bit more later, you can do both stateless and stateful. So for maybe the younger members of the audience who may not know what that is, stateful, it's where you maintain you know, a mutable authoritative state of data, whether that can be like a shopping cart or, you know, you're logged in with credentials. That specific data has to maintain itself if you come on in different instances. Where a stateless, you know, that can be a proxy. It just doesn't matter. There's nothing. There's no mutable, you know, aspect of that needs to be the same across instances, and that'll become more apparent when we talk about instances versus replicas. All right, so with all of that kind of high-level stuff, we do want to show you an actual Service Fabric solution. Oh my. All right, so this is called CSP Boss. This was originally written as an app service, a platform as a service solution. And with considerable effort, we re-architected it into an Azure Service Fabric solution. Thanks to Erick, who's our genius senior software engineer, and a team of programmers that we had working with us. May not look that interesting, but it actually processes this. We use this solution for about 200 CSP clients of ours. We resell this solution to about 50 other Microsoft MSPs, and it processes probably about 900,000 a month. So it is a critical, transaction-based solution. And we are very, very happy that it is running Service Fabric because we are a small department. To give you an example, a competitor out there who has more features but does a lot of the same stuff, they have 400 developers. Right now it's Erick, myself as management, and then a team of 3. So looking at the new architecture and understanding the architecture and designing for that is critical for successful solutions. Just making that as a general statement. Yes? Very, very similar concepts. And in fact, in Azure, there is AKS, which is Azure Containers as a Service. I know it's a K, not a C, where they're very similar to Service Fabric and a great solution. Again, one is not better than the other. They're just 2 different approaches.
The main reason was to have microservices. That was the main reason, because with an app service plan, you cannot scale properly. You have to scale everything at once. With this, we have microservices. So sometimes, for example, every night in the solutions he was showing, we have, I don't know, even millions of operations to Microsoft to update, to sync with them. So there's no way we could handle that with app services because the cost would be huge in order to scale out all that for all the services. In this case, we only have to scale out what we call the actors, which is something probably going to show later that service already has. Actors are meant to be run in terms of thousands, even millions, at very effective cost.
And that's, I think, a critical point of just in working in Azure in general as a software engineer. It's understanding the different pieces and how to develop for them while paying attention to cost. Because it's very easy to build something and all of a sudden your Azure utility bill starts going way up. If you understand the pieces better, participate in forums and talk to other engineers, you can start figuring out, oh, if I design it this way, it's not just performance and scaling now, it's also making sure you have costs in check. It's just another piece that software engineers have to start thinking about, or at least the architects on the team. So this is a comparison of platform as a service and Service Fabric. The idea is in platform as a service, you have a node, which is essentially an abstracted virtual machine where you're running something. Each one of these colors on the left represent a service. And that node is completely consumed by that service. and then you have the number of instances of that particular service. And that's great, and platform as a service is wonderful because it can scale up and scale down. It does clustering for you and load balancing. However, to get to greater efficiency, to get on always on and rolling upgrades where you just upgrade little pieces of it and you don't actually have to bring the solution down, the service fabric slide represents multiple services on a single node with different combinations and different numbers. So it's more finely grained services. And another great piece about Service Fabric is it can auto-heal. If there's an issue, it can move everything over from a stateful or stateless operation into another node, rebuild itself. It will deal with all the clustering and load balancing as well. There is more to it, but any questions about what this slide represents? All right, so Azure Service Fabric. You can run it in Azure or on-premise or public data centers. So in this case, I'm presenting this as if it wasn't running in Azure, and I'll explain the differences. We have 5, it could be a PC, it can be a virtual machine, it doesn't matter. In Azure, it would take care of this for you. But you typically start, the average cluster size is 5. And you install the bits and make those boxes part of the Service Fabric cluster. And then you tell the boxes about each other. And that sets up the communication between those 5. Now, if this was in Azure, it's automatically going to do load balancing for you. But if it's not, put a load balancer in front of it. So let's say you're deploying code onto the box. You deploy it to one of the nodes in the cluster, and anyone here familiar with Puppet and Chef? So it's going to kind of copy your code across all the members and maintain the same configuration state across them all. So that's nice. Deploy once. You don't have to go to 5 different machines to do it. Now, on the user side, let's say your application is deployed. Again, they hit the load balancer. In Azure, it's already there for you. If you're running this Amazon, you set up a load balancer in front of it. It's going to direct the person to the most available node, and we'll look at what, how it reads the health. Any questions on this slide? All right. So we'll just go through a couple more fundamentals, and then we'll actually show you Service Fabric, what it looks like in real life. The components, and I realized earlier that I left one off. It's a DNS service, but these are the 5 primary components. I'm sorry, 6. You have the cluster manager, which is managing the cluster. You have the failover manager, which is going to deal with failovers inside the cluster, and if there's a health issue with a node, it's going to move everything around. Naming is just mapping instances to their endpoints. Fault analysis, it allows you to essentially test out scenarios in your solution. Image store is where all your app packages go, and then there's the upgrade service. Now, you'll only see the upgrade service in Azure, because if you run in Azure, it's going to automatically take care of Service Fabric upgrades for you. If you run it on premise or in another data center, you update the bits, and that gets replicated. So for instance, if you're running Service Fabric locally, which we're going to show, you would manage the upgrades. And I just want to point out again that it is running the exact same bits that it is in Azure. So when you're developing and testing, we typically do that on premise or in different teams. And then when it's ready for production, it's moved into Azure. I don't know. I'm going to skip over a couple things because all right, let's talk about Service Fabric Explorer. Now, I have some terrible screenshots, but we're going to show you what it looks like. You can start and stop your cluster from the interface. I think what's interesting about this one is this is going to show you the health of your cluster and what's running in it, and it also you can use it for a lot of troubleshooting. There's an applications section. It's going to show you the applications. In this screenshot, this was created with no apps. You know, looking at the URL, localhost, you can tell this is local. If you have something running local and then you push up to the cloud, you can actually just change that endpoint, and you can also see that we're starting on node 1. So we have applications, nodes. In this case, we're running a standard 5-node cluster. You can check the health of each of the nodes. And then system. So when we looked at that slide earlier with the 6 components, this is where you see those components. These are part of the Service Fabric system that are running in Service Fabric. Now notice there are only 4. We have the cluster manager, failover manager, fault analysis service, and the naming service. We don't have the image store because you get that when you're running it in Azure. And we don't have the update service because that only exists when running in Azure. This is running locally. Now the one that's left off here is the DNS service. It's optional, but it's definitely a good thing to be running. And just to show you those again. Now to show you what this looks like, here we have, you know, Eric, can we do this to duplicate? I'll switch it back. This makes it easier. All right, so this is Service Fabric. You were seeing screenshots earlier. This is actually Service Fabric is running on this machine. This is local. This tab over here is running in Azure. So you can see a couple differences between the two. Again, here's the applications. Local, it's not running an application right now. We have the 5 nodes. You can see the health status of them, and you can see the system components of the Service Fabric cluster. Now, if you go to the cloud version for applications, notice there is an application. Now, you can have multiple applications running in your Service Fabric cluster. In this case, we just have one, and we'll explore that a little bit more, what that means. Now, notice in the cloud too, we added the image store service and the upgrade service that didn't exist on the local side. Any questions about this piece? All right, so you can have multiple applications, and in Service Fabric we call them application types. So in this example we have an eStore application type, and this eStore consists of 2 service types, gallery service and payment service. Now in reality you might have 10 services, 20 services, 30 services. But this is just a simple example. This is a very simple e-commerce app that has 2. So in your cluster, you deploy this. It's going to pull your resources from the image store, and it's going to set up a named app. Now, this first name app is Contoso. You can have another instance of that named app, in this case, Fabricom. So is this the right setup for you? It might be. This is not how we use it, but you could have different instances of the same application type for multi in your solution. It just depends on how it. Questions? All right, so to build on that example where we had the application type, service types, and then the 2 named applications in the cluster. To kind of illustrate that more, you have the cluster, you have 1 or more named applications, you have 1 or more named services that exist in each application, and then you have your partitions. And that's when we get into stateful and stateless. And the primary point that I want to make with stateless and stateful is the difference between instances and replicas. With stateless, it doesn't matter. You just spin up another instance of that same service. It doesn't need to maintain the data or the shopping cart or the, whatever across all the instances. Just another instance. With stateful partitions, it's an actual replica where it's using the exact same data no matter which replica of that service that it's using. So under the named application, you have a named service. So you could have multiple named services, and you can have then multiple stateless and stateful partitions of that app. So hopefully that makes sense. And then Eric, you were gonna talk about that further.
So, does it work? Okay. You know what? I'm gonna use that thing here. Yeah, I think this is better. So, let's see an example of a stateful service running in a local environment. As Jason said before, the same bits of Service Fabric running in the cloud is the same have running on this demo locally, and but it's only that Service Fabric is the only thing that is the same everywhere. But locally, we don't have things that we have up there like public IP, load balancer, virtual networks, or actual 5 nodes, because this is only one computer. Up there, it's in this example is 5 actual VMs or PCs. So, and there are more things that you get when you request Service Fabric from Azure, like CERT or Azure Vault, things like those, that you could have Service Fabric installed anywhere, on-premise, on Amazon, everywhere you want. But if you actually go and install it, request it in Azure, you get all this configured out of the box. Configuring all this yourself could be a challenge. Okay, let's see demo. So in this case, we are gonna see a stateful service with 1 primary replica and 2 secondary replica. What that means, this 1 replica is the one that is gonna actually do your job, is the one that is gonna be processing whatever you want to do. And the 2 replicas is only to maintain the state of that partition. So when you use the Service Fabric programming model, you get access to what they call reliable collections. That means everything you put in those collections, in this case we're going to use a dictionary, Service Fabric takes care of replicating that across your cluster. In this case, if we have 2 partitions, it's going to be replicated into those partitions, and it's completely transparent to you. So this case is going to be really simple. We're just going to read from the dictionary, print that out as a Windows event, update dictionary, content up, and then commit the change. If for any reason an exception or something happens between this using statement state, so it's gonna throw an exception and nothing is gonna be replicated anywhere. It's like going back to 0. So what we're gonna do is I'm gonna run this locally. Anyway, you're right. It's better if we duplicate run this. The only we care is this. We read from the reliable collection and we write to the reliable collection and we just commit that. So let's run that. And it's gonna run here. We see this is local, and it will pop up here in a few seconds. So what I'm going to do is I'm gonna restart the node where the primary replica is running. So let's see that. Okay, it's ready to the type. Not quite ready yet. So let's do this. So what we are seeing here on the right is the event viewer. That I don't know if I can increase this font size, but I can take a screenshot and put it on Paint or something when we have actual data to see. So we can see here we have the stateful service, we have one partition as defined, and then two replicas. Primary, and I think I can make this. So we have the primary replica and two secondary replicas. It's not ready yet. Let's wait for it. So we can see that the primary replica is running on node 3. It's right here. Okay, all of those are ready. Again, node 3 in here is the one that I'm gonna shut down in a second. But let's go back to Visual Studio. We are seeing here what we were printing out is a count, 0, 1, and so on. So those are the values that we have put in the reliable collection. So the goal here is when I restart that node, we don't lose any value. It continues what it left. So we're gonna go to node 3. Let's restart it. It could be like a failure, anything, got on fire, got there and cut the cable, whatever. Okay, we are starting that. Let's go back to Visual Studio, and then we are gonna see here an error soon. Well, you probably cannot read it from there, but here it is stopped. It says, okay, we're moving this, we are promoting a secondary instance, and then it continues the countdown. If we pause this for a second, we can see the previous instance, the previous replica was on 52, and then it continued on 53. So no data was lost. That's the point of using partitions. And now, before the primary replica was on node 3, and now the primary replica it's on node 4. So it's a bit fabric, just moved the code, kept the state, and all that was transparent to you. You didn't need to worry about, hey, how do I move my service or any of that. So that's one of the cool things of a stable. So I'm gonna stop this and close it, and I'm gonna close these two. Okay, there you go.
All right. So any questions about Erick's demo? So what we were hoping to demonstrate there, and there are a lot of great tutorials on the Azure website. So if you're looking for those, go to azure.com. That will take you to azure.microsoft.com. In fact, let's go there. So azure.com will take you to azure.microsoft.com, and if you click on products, under compute, right down here, service fabric, go to documentation, and there's tutorials, there's concept. It's easy to get started, and what we're hoping to demonstrate is kind of introducing you to Service Fabric if you're not aware of it, and then also show you all of the great things about it, all the magic it's doing behind the scenes for you, for having a scalable, always-on, rolling update service, auto healing, all these wonderful things that would always have been nice to have, and now we do. And as software engineers or in the DevOps role, you know, ideally we want to simplify our lives so we can focus on creating the value and not get entangled up with all those other things.
In the web.
Right, so if it does look complicated and confusing, you just start using a little bit and you find out it's not. The Explorer you were seeing before is how you can manage it.
Yep.
The change, though, is if you have an existing application, there's a lot of folks when doing software development in Azure, you start with infrastructure as a service because that's what we're all used to. You have code running on a VM. Maybe it's an ASP.NET MVC solution. And the next step is you move it to platform as a service to start taking advantage of all those, you know, auto scaling and load balancing for you. When you go to Service Fabric, that will require a re-architecture, different than from when you went from infrastructure to platform as a service, because there are a number of fundamental things that are different, and you have to start then more finely layering your solution into different services. And then you create the communication, the intra-communication between and among all of those services. You get to take advantage of things like Service Bus, so you have reliable, durable messaging between and among the apps. So there is a re-architecture effort. So if you start with a simple web app that you have and you start going through the exercise of, I wonder what it would be like if I re-architected it, you know, that's a good place to start. You know, start simple, don't start complex. We'll be making the slide deck, which, you know, is somewhat useful to you. It's more that what we're trying to kind of show you, but there's some links in here around that. We do want to talk about health a little bit more, and I think Eric was also demonstrating that. You saw the green OKs. So green is okay, yellow is warning, red is error. But the thing is, it can automatically heal itself and move stateful or stateless workloads from one node to other nodes, intermix services on those nodes. It is designed for always-on, highly available, in a way that many people aren't used to, unless you have, you know, tons of VMs set up with a load balancer, and even still, you don't get the same level of kind of failover that you get in a Service Fabric cluster. Anything you want to add on health? And one thing that's also useful, you can run Service Fabric on Windows, or you can run it on Linux. And there is a performance difference. You can get, you know, things. Well, there is a performance difference. Running it on Linux is faster, but running on Windows is very, very fast as well.
So let's talk about how what happens when you have to update your services, let's say bugs or new features or whatever. So for this, Service Fabric uses the technology called upgrade domains, which is pretty much how much of your service, what capacity of your service, of your services is going to be up or down. So in this example I have here, I have 5 instances of a service, and I have a configuration of 5 upgrade domains. So Service Fabric goes 1 upgrade domain at a time. So when it's updating instance 1, that means I have 20% of my capacity down. So the other 4 instances have to handle all the load, all the traffic. So There is these upgrade domains, the number of them you configure at the time of creating the cluster. And I'm saying that because I don't think you can change it later, but you do need to pay attention to that, because having too many could be a problem, but having too few, it's even worse. The only downside I see of having too many upgrade domains is that it takes a lot of time to update all your services, because Service Fabric, let's say, goes with one upgrade domain. Once it finishes with that, it performs several health checks, and that takes time. It makes sure everything is fine with your new version of that service before moving to the next upgrade domain. And believe me, it takes a lot of time to upgrade many upgrade domains. So if you select too few, well, if you select one upgrade domain, it's obvious what the problem is. When that upgrade domain is being updated, your entire service is down. There is no instances that can take that load. If you have, let's say, two, well, half of your service is down. So the older service had to take all that load, and that's probably going to fail. At least you have enough capacity. But if you have enough capacity to take that in, means that when you're not updating, then you're wasting a lot of capacity, because that node or that service is doing nothing, or just not using the entire capacity it has. So the other good things of having upgrade domains, this technology, is that you can keep hitting your services while the update goes on, because you have multiple instances. It's not like they turn off everything and update everything at once. One thing you need to keep an eye on is that you will end up running different versions of your service side by side, which for me is a good thing, but in some scenarios could be something to pay attention to, especially if you have like schema changes, your database schema changed, so, or protocol change, like we have two microservices talking to each other, and if you update, you can end up with version 1 and version 2 running at the same time, and they're not going to be compatible. But that's completely unrelated to Service Fabric. In that case, you just follow one of the patterns out there, like deploying in 2 stages, or having one deploy with all the code, backward and forward compatibility, whatever you want. So, but it's a good thing to have upgrade domains. I'm going to show an example of this running of 5 instances. So when it's time to update, Service Fabric has 3 modes. Monitored, which is what I just said before. It goes one by one, and after finishing with one upgrade domains, it makes sure all the health of that it's fine, because if it's not, then it's going to roll back automatically that update, and that could be the end of your update, which, by the way, is another good thing. A monitor auto, it's Service Fabric is not going to check the health. It's going to always go on and go on and go on. That type of update is faster, but is risky. And the third one, it's when it doesn't monitor anything, but you do have to manually move from one upgrade domain to the other. It's not Service Fabric doing it for you. So in this example that I'm going to show here, I'm going to be running it against the cloud. So I'm going to have this console up is 20 threads hitting the cluster. This one here. I'm going to have this stateless service with 5 instances. It's just a web API, simple. The only thing that's returning is this. Let's show the web API. Is that. And the console app is just hitting it, 20 thread concurrently, no sleep, no anything, is just hitting it. So what I'm going to do is I'm going to change it to another version and deploy that while that is running. So I'm gonna change it to something really easy to see, something like that, so we can see the difference in the console app. Gonna save that. So there are several ways to deploy your application, to update it. You can use the PowerShell command Jason was showing before. You can use Visual Studio, which on the back is just using those PowerShell commands. So first of all, you need to update the manifest version, as those are XML. I don't see the point of going into that right now. But one important thing is, even when we are showing numbers here, Subway doesn't care about that. Those are the strings. I could have going from Monday to Tuesday, and then going back from Tuesday to Monday, and Subway is gonna always update, because the only thing it checks is that the two strings are different. If the same service goes with the same string, it will just skip it and not update it. So in this case, I'm gonna update my service, the API. I'm gonna put it here 1, and I do this 2. So I'm gonna move from version, and see here. Okay, I think, okay. So we can see here that I'm running version 1, and it's gonna move to version 2 soon. And also we're gonna see the upgrade domains in here. So let me put this to work. It depends on how fast the connection is. It should go fast. We don't need to see it all the way to the end, but okay, it's building. Not yet, still building. My computer is the one that is not fast. Okay, there we go. Let's wait for this to say we are okay to deploy. Right now, he is just making sure to have the proper authorization to deploy to that cluster, because this cluster is live. So it's secured with Azure Active Directory, and entering that subject now. But okay, there we go. It's gonna take a few seconds. So in the meantime, if you have any questions, because this looks like it's gonna take like a minute. And this keeps working, and then I'm gonna put this side by side, like in here. All right. In my personal opinion, and this is my personal opinion, cloud services are dead. They were dead a long time ago for me. It's actually the first service, one of the 3 first services that Azure had when they released. When was that? Like 8 years ago, 10, 15? 2010, 8 years ago. So it's like one of the 3 services they released. So as you can see, things have evolved a lot. So for me, it's dead, but it's my opinion. So after that, we have app services, which is different. And then I'm not saying these are gonna replace app services, because depending entirely on your solution, but I haven't encountered any solution lately that I wouldn't use a microservice architecture. It depends on the size of the project, but now we can see it's working. We have the 5 upgrade domains here. It's working on upgrade domain 1, or in this case 0, and here we still see we get reply from version 1. We don't get any errors, any HTTP error, anything. So when we see something in yellow, it's gonna be something different from whatever that string is. That I just added it to help us see when we get something different. So when this turns green in here, it means that that upgrade domain finished. We have some yellow already with the new values. I mean, what we changed in the API, the equal signs. So now what we are seeing right here is one of those or any of those 20 threads, it's hitting the new version, and there are all the threads hitting the old versions, and that is happening side by side with no error. So your service is completely up. Do you want to say something?
I just want to share in the excitement of watching the 5 nodes. One's being upgraded. You can see the change. It's going to move into the next update domain. But to add on to what with the question earlier about app services, you know, from a purely design perspective, there are numerous advantages to containers, Kubernetes approach, or a microservices platform. Now, building an infrastructure service or platform as a service, it's not dead. It'll be around for quite some time. It's really just a transition of as people learn the new skill sets and the reasons why you would want to use containers or a microservices platform. So they aren't going away anytime soon. I suspect they'll be around for quite some time. But it is very worthwhile, and as you can see, we have 2 greens. It is a great time to start looking at Service Fabric, as well as a number of other technologies. .NET Core is very exciting. Anyone working with .NET Core? Okay, so .NET Core and Service Fabric together can make an outstanding solution.
We really don't need to wait for this. Eventually we'll turn green all of those upgrade domains, and it will be green here or yellow in this case. So okay, let's you know.
And the one thing to just be clear is you could have a production system running and you're upgrading without ever putting it down. And that does change the feature of
Yeah, that's something we actually do. We, in the solution that Jason was showing before, CSP Bus, we are not afraid of deploying at 10 a.m. or any time of the day.
So this means that Erick doesn't have to be up at 2 a.m. anymore, because the solution that we have in production is used actually all around the globe. We have folks in Australia and New Zealand using it, but we don't have to wait to off hours anymore to deploy updates. So that's important, as well as, again, always on.
Okay, that was it. All yellow on this screen, so it's like all the 20 threads are just hitting the new version now. So okay, I'm gonna close this. I'm gonna go ahead. Mm-hmm.
Backwards on all of them?
Yes, everything goes back. Everything goes back to what you had before. But that's something again you can configure. By the way, everything is configurable. So you have that. And let's add one more thing here. You no, there's. Do you want to say something?
Yeah, I meant to talk more about that earlier, but that's a great question. So what happens if something fails in the upgrade process for some reason? Using the health check and the health monitors exist. If it detects a failure, it will automatically roll back for you. It's not a manual process that you have to do. It will automatically roll back for you, which is another nicety. And everything we're talking about is also configurable.
So let's see how this works. So it works fine. Okay. So let's go with the presentation. Okay, let's talk a little bit about Cluster Resource Manager. It's a great feature. Is awesome because it's one of those cool services that allows you to get control of where your code is going to run, how it's going to be deployed, and allows you to report load. So for that you have placement and capacity properties. Let's see what those are next. So
we got an example here. This is the best way to understand this. The placement property is just a key value pair, 2 strings. And the capacity properties is another key value pair. In this case is a string and integer. So it's better to explain it with an example. So let's say we have a 12 node cluster, and then we have let's see if I can write in here. And we have placement properties like, no, it's not writing. No, anyway. So we have placement properties. In this case is continent, front end, and we have capacity property like disk. So what that means is when I create the cluster, the node, I put a tag on it. In this case, the tag is continent and front end with a value. So we're gonna use those values later when it's time to deploy your service to tell Service Fabric where you want the service going. And the disk is capacity property. In this case, we just put GV just for bare reading, but Service Fabric actually doesn't care about that or units at all. It's only about an integer, which has a meaning for you, not for Service Fabric. It could very well be 100 gigabytes or kilobytes or whatever. So we have this cluster. So now let's say we tell Service Fabric, hey, deploy 4 instances of this color there, whatever that color is. And we have a placement constraint, is you can only deploy this where front end it's true. So the only value nodes is 1, 2, 7, and 8, and that's what it does. Now let's say we want to deploy 3 instances of this second service. Now we have multiple constraints. In this case is continent has to be America, front end has to be false, and disk has to be 50. So it has to, that is a capacity that it has to feed in order to deploy there. So it could be the only available options is 3, 4, 5, and 6. And Service Fabric choose to deploy in those 3. So now let's do the same with this red new service, and it's fine. It could have put 3, the instant 3 in any of the older 3 nodes, but Service Fabric always try to be balanced, so it's better that way. So we're going to talk about that optimization next. But what happens if this instant 3 of this teal color there needs more space? It reports a different load, it's going to grow. So then you just need to report it, and Service Fabric is going to take care of moving the service. In this case, rebalance the cluster. And again, that is completely out of the box. You don't need to worry about that. It's your code, the one that is saying, hey, I need now 100, period. And by the way, you can only do this if you're using the Service Fabric programming model, which it makes a difference, because you could also have in the cluster guest executable, and then you cannot take advantage of this. So, okay.
So, just in case the pizza coma hit you, I just want to capture the immense excitement around this last slide. If you think about managing and scaling your application, what he's showing you is essentially through tags and creating constraints. You can tell it, I need this many more of this with these constraints. You don't have to be concerned about all the nodes. It's going to automatically figure out where to deploy it based on those nodes for you. So it becomes a very easy way to scale as you add resources, and as he also showed you, to change. And that's when you want changes or scaling to occur in different fashion. So very, very exciting.
You can keep it on this way. Okay. So let's talk about one more thing of things of resource management. It's the metrics. So metrics are the resources your service care about. We have physical services like memory, disk, CPU usage, things like those. And we also have logical metrics. It could be whatever you want. number of messages, customer size, concurrent connections is XYZ, things that I'm making up because it only has a meaning for our code. And the metrics have this property, name, the load, which is an integer that you report to the cloud, so the cloud can balance the cluster. And the weight, it's only to tell Service Fabric how important is one metrics over another. In case we need tiebreak or something, that's what it's used for. So let's explain this with an example. Let's say we have a cluster, 4 nodes, 3 services, green services, black services, and orange services, 2 instances. And what we have in the box is the report, is the load they are reporting. Let's say I have a logical metrics called concurrent connections. Why I have that? Not because anything in the cloud, again, it's my code, the one that's going to use that. I'm going to explain why next. When we have VMs or PC or anything, we have physical constraints. We all have that. We all have a certain amount of CPU or I/O or anything. You have limited resources. So in this case, let's say it's an application that has a lot of outgoing connections, like concurrent connection to the outside, HTTP requests. So if you put if you have 2 instances, let's say black 2 and green 10 in that node, and for some reason the green becomes a noisy neighbor, that is going to affect your service number 2 because it's going to eat all the connections that are available for your node. So you don't want that. So you want Service Fabric to balance the cluster so that doesn't happen. So in this case, that is what I have that. So let's say this cluster looks pretty balanced because if you see the node with the most load is 3 with 12, and the least is node 2 and 4, and the ratio between them is 1.2. So it's pretty balanced. So that's good. But what happens is that the one in node 2 reports a load of 8. But in this case, it's not as optimized as it could be, because a better balance would be moving this black 2 there. So we have now a ratio of 1.1. You might think, yeah, is that enough to balance the cluster? Maybe not. It's up to you. But again, those numbers, it's whatever you might think, because maybe I'm using like 2, but what I mean is 2 million connections instead of 2. So if you think that value, I mean, how you tell the Service Fabric that little difference is enough for you, well, the weight we were talking about before, if this metric is high, the importance is high, well, you're telling Fabric any variation of that, I want you to take action of it if it makes sense. Okay, one last thing to add here. When you report a load, it doesn't take effect instantly. There is, by default, Service Fabric waits 5 minutes actually anything, and that's configurable. That's in the cluster manifest. You can change that, but you need to keep an eye on it. You don't want to put it too low, because Service Fabric it's running, it's competing with your code. It's running in your same clusters, it's the same VMs for everything. So if you've changed that time to 1 second, then you're going to have the resource manager service consuming a lot of resources every second of your cluster. You don't want that either. So what I'm trying to explain here is you need to be proactive with the load, but you also cannot be like, hey, I reported 8, I'm expecting having those resources available, I'm going to start my code right after that. The code needs to be aware of the configuration of your cluster. And yeah, that's it. Any questions about that or anything?
You're deploying a web app you're deploying a container, what's the unit of things that you're deploying? What are the other types of things you can deploy?
You can deploy both. You can deploy web apps. You can deploy just code without any state. You can deploy like what you might know as worker roles in the cloud environment, and you can have containers as well. And you can even have an exe running in the cluster.
You're deploying there is a your demo code that was just returning the version that's stateless.
In this example, it's a stateless, but it could very well be a stateful as well. It could be anything that uses the parameter model of Service Fabric, which pretty much is using the SDK, as simple as that. It's your code using the Service Fabric SDK and reporting load.
What else besides the C++ or the C#? Sorry. What else can you deploy?
So far, the SDK it's for Java and .NET, and I don't remember what else. Ruby as well. It's like 4 or 5, but I don't know. I just familiarized with Java.
They've been expanding it because their goal is to be able to allow you to run whatever language you prefer to develop in.
But at the end, if whatever they are doing does support the language, you can put it in a container and put it there. And you will still have the greatness of Service Fabric as orchestrator. Because Service Fabric is like Kubernetes, an orchestrator, but it has a huge plus. And this plus is the Service Fabric parameter model. We have just mentioned here like tiny things, seriously tiny things of that greatness that comes with the Service Fabric parameter model.
In order for, at least in my, in order to better understand it, I don't know if you can provide like an example of how, for example, if I have a multi-tier application already in Azure, but only pointing like to different services. Let's take scalable SQL, right, for database relational data. Then I have table storage in the same application, right? Just to dump like auditing data, for example. And then I have my Redis, right, to maintain all the caching from my 3 app services that are running, right?
Okay.
At the same time. And then I have an API and maybe a couple Azure functions, right? So that's basically the architecture. How could I take that same architecture and put it into Service Fabric?
So you have mentioned it. You have mentioned services that are outside of the fabric. Actually, what you put in the in the cluster is your code. You don't put your SQL server in the cluster. You could, for sure, you could. No, there is no question. You can RDP those VM and install whatever you want, right? But the idea with Service Fabric is to keep the data within the cluster. That is why you have the stateful services. In this case, if you need a SQL server, it's going to be outside of the cluster. Is your code the one that's going to be inside of the cluster?
So I cannot like install it in one of the nodes. It needs to be outside.
No, you can definitely do it.
That's what you're saying, or
you can definitely have it inside of the cluster.
How?
I'm not sure I recommend it, but you can.
But how?
How what? Oh, you can just RDP the VM and install it there. Are we talking about SQL service as a service?
SQL Azure.
Oh, Azure SQL service as a service. Then no, you cannot have it inside. It has to be outside.
Neither table storage?
No, it's outside.
Neither Redis?
Outside, right.
But for those services, those are perfectly fine running outside of the Service Fabric cluster because they're, in a way, they're already running in Service Fabric, which is running Azure. So all of the as a service offerings in Azure, most of them are managed by Service Fabric. So they're already clustering and load balanced and self-healing on their own. Right. So This is more for your code. If you want to bring data in, you can, but if you're using Azure Storage or any of those, you're fine already. So just think of this more for your code. And I'll just throw out two other services, right, for your app code. Two other services that are definitely worth thinking about if you haven't started playing with them yet are Event Grid, which recently became GA, and also Cosmos DB. Cosmos DB is kind of based originally on MongoDB. It was Document DB before. Think of it as, you know, if you could rewrite and re-architect how that worked, that's how we got to Cosmos DB. So it is a very exciting offering. Cosmos DB. Another.
Yeah, that's the future.
I'm sorry? Okay.
You guys aren't there for mention.
Yeah.
Okay, let me just throw out one last piece. So earlier I mentioned, you know, working many hours, and part of that is because I have a lot of responsibility in my new position, but also in the last year we've experienced a 4x growth. So I would like to think, and I've spoken to many colleagues, a lot of people are seeing a big increase in work in the Azure space. Azure is many things. It's very wide. You have DevOps, you have software development, you have infrastructure, big data, machine learning. So many people I've spoken with have been seeing this growth as well. It is important to take a look at the new tools and the new services. And where's Alex? Alex, how many high-paying positions are out there that are not going filled right now? Okay, lots. Now, the problem is, of course, Alex, are they looking for people without experience? No, everyone's looking for someone with experience. So how to get experience? Because they really want to hire people, and it's really hard finding people with experience. So what Alex showed earlier, the Get My Interns, or the project he's working on, sometimes you can take a new service, or like Service Fabric or Kubernetes, start doing a proof of concept, then find someone you can on the side be part of a project for, because you can add that to your resume. Or if you are a member of a church or a synagogue or a nonprofit, they might have some IT needs that you can apply that skill you're learning to it, and guess what? All of a sudden you now have experience. And there are a lot of employers out there, and Alex can attest, there are many unfilled high-paying positions where they're looking for the new skills. It is hard to get the experience, but there's actually a way you can. Start donating some of your time, building out using some of these new skill sets.
They're like, yes, finally, someone with this on their resume. So it's definitely worth it. It's worth doing the project on the side, pro bono. Just get the experience so that you can share with that manager what that manager wants to hear. Thank you.
Right, and to add that one step further, especially some of the new skill sets, whether it's .NET Core, and a lot of you raised your hands, Service Fabric, Event Grid, Cosmos DB, start looking at some of the new services where it seems clearly defined that these are going to be very important. Those are good ones to focus on.
I have questions. Are you guys done? Yep. So I wanted to hear a little bit more about your experience in re-architecting to fit into Service Fabric. Are there any anecdotes or particular examples of what you had to do?
Do you know I'm sure everyone here has experienced that point in time where 3 hours, 8 hours, 12 hours have gone by that you could never reclaim in your life because you were banging your head trying to figure out something. You went through that pain, then you learned it. Now, of course, a version or two later, it works, and those new people don't have to go through that, but yeah.
So most of the problems were this service fabric didn't work the way you expected, basically, that kind of thing, or was it like dividing the problem up differently? You had a
I would say we were kind of lucky because we actually started with the monolithic application, so we knew already what was wrong and what we needed to move into the microservice architecture. So regarding service fabric, what was the challenge? It's like service fabric is huge. Yes. Mastering it took a year or something. So it's not like app services plan in Azure that you can master that on service fabric is huge. If you really want to build an application and have it monitoring, we haven't even talking about the health system or the monitoring system, so you can react to events that happens in your cluster, things like those.
Were you able to take like the monolithic application and like break off a piece, put it up there, and break off another? I mean, like test it along the way. Okay.
Yes. And after we did that, we broke it into several places, several microservices. We deployed that. And once we had that running for a couple of months, we kept adding more microservices and more microservices. Okay. And it's easy, as you can see, we don't need to take anything down.
Right.
We can do small updates.
And so were you taking the bigger microservices and breaking them down, or just adding new things?
Probably we are not yet in what Netflix has with the nano services, but we are not opposed to that.
And what was the splitting up the monolithic pretty clear where you should split it?
It was clear because we had it for a year or so, monolithic. We realized really soon that that wasn't the right path.
You had a lot of experience with it.
Right. Well, the application, the particular one, it started as not a multi-tenant solution, but we knew that if it was successful, they would want us to turn it into multi-tenant. So we actually went through. This is the third generation of that software product running in production. Right. Our CEO had the idea and then said, build this, and we built it. I think what I observed is one of the challenging parts is, in going through these examples, Eric was pointing out a lot of areas that maybe aren't traditionally part of software engineering. And I think, one of the areas that kind of expanded everyone's head and working, and then we're starting up another service fabric project for a client. So we do it both for internal and also for client facing.
All right, well, thank you. There's some free magazines and some stickers, a couple books. Please help yourself. Same with the soda and water. Take everything. I don't want to take anything home. Thanks for coming. Thanks to Eric and Jason. And Damien. And Dave.